Good morning, dear students. Welcome to another session of Verilog HDL. So, in a previous class, we were discussing regarding a recap of some of the concepts related to behavioral modeling. So, in which we discussed what is meant by behavioral logic, behavioral modeling, and uh, how it is useful in multiple tasks as compared to the previous one what we have dealt, that is data flow modeling and gate level modeling. So in that we discussed regarding the structured procedures, that is always and initial blocks, how these always and initial keywords are utilized for declaring the always and initial blocks, and how the execution goes around in initial and always statement, or how the blocks are being executed. So these are the things what we discussed in uh, previous session. Then apart from that, if I have to just recap these things is we have something called as procedural assignments, in which we try to update the values of register data type, integer data type, real data type, and time variables. So this is we can do it by assignment operation. So in that again, we had seen that we had different kinds of operations specified over there. So in general, what we have is this is a syntax, that is left side value and right side value. It can be a single term or it can be a expression over there. Now, as per the rule, right, left hand side of the assignment operator or the procedural assignment, we can have register data type, integer data type, real data type, time register variable, and a memory element. So any of these can be put on the left side of the assignment, procedural assignment. And what can be on the other side? Apart from these, we can have just a selected bit on the left side, or a set of bits from the given parameter or the variable. Or else we can have even concatenation possible. So these are the possible values on the left hand side. And on right hand side, you can have any expression with say all with the operators what we have discussed previously in the data flow modeling. So we can have any expressions on the right hand side. And these expressions should evaluate to a particular value which is supported by the left hand side value of this assignment. So these are again in general what is meant by procedural assignment. Again, in that we had discussed two things, that is one is blocking and one is non-blocking assignment. And we had seen how these two are different from each other. Okay. So in blocking statements, what happens is the execution goes in a sequential form. In blocking statements, in blocking assignment statements, the execution of the code goes around in sequential form. So what does sequential imply in this case? So we'll be discussing again this in later sections. So here we can, and the operator which is used for blocking assignment is equal to, and for non-blocking, if you remember, it is equal to and greater than sign. So we'll just check out those also. So here you can see that you have declared some variables which are of register and integer data types, and in initial block within the begin and end statement. Therefore, these are having multiple statements here. So you can see that there are some assignments which are being done using this equal to operator, assignment operator. So here what the sequential imply is, after x is equal to 0 is being assigned, then only y is equal to 1 will be initialized. And then after that, z is equal to 1. The time difference might be very small, delta amount of time, but this is how it goes around. And another thing to remember is all the executions generally start at time t is equal to 0. So here you can see that all the executions start at same time, but what happens is y's assignment is done only after x is assigned. Then z's assignment is done only after y is assigned. So in this way, it goes around. But when we look at the timing diagram, right, all of them start the execution at time t is equal to 0 or 0 time unit, what we specify in general simulation at 0 time unit. So what happens is at 0 time unit, X, Y, and Z all start their initialization, but initialization of Y or assignment of Y happens after some delta amount of time after X has been assigned. So here what happens is, if you look at the timing information, all the statements from this point to this point, that is count is equal to 0, reg is equal to these things. So these three statements, if you just see, we don't have any delay specification over here. So all start their execution at time unit 0. That is when the time is equal to 0 in the simulation case. But Y's assignment is dependent on the previous one. This has to be assigned. Z will be assigned once this Y is being assigned. After that, count comes. Count will be assigned as a value of 0 after Z is being assigned. So this is what sequential implies. So then apart from this, what happens is even this statement, right? It also starts at time t is equal to 0. But what is happening in this case? It'll here, since delay is specified, the assignment will be happening after 15 time units of delay. Now, next statement, if you just look, this statement is following the previous one. Now, since we specified that it is sequential, so in this case, what happens is this also starts at time t is equal to 0, but its assignment, that is reg b's assignment, will be starting after this execution, after execution of the statement. That is the statement after reg A has been assigned. So what happens is after 15 time units, reg A is assigned, then 15 plus 10. So after 25 time units, reg B will be assigned a value. So this is what happens in the blocking statements, blocking assignment statements. Okay. So then coming down to the non-blocking statements, non-blocking assignments. So in this, we make use of this operator, that is less than and equal to sign. Less than and equal to sign. If this operator is seen in the assignment, then it is implied that this is a non-blocking assignment. So basically, the name itself tells that it does not block the operation of the other assignments. Whereas here it depends on the previous one. So Y's assignment is blocked because of X. So once this is done, then it goes to the next one. But in this case, that is not the scenario. But there is slight difference compared to blocking and unblocking. Say the way it is written, syntax, then the operator which is being used. Then in blocking, it is sequential, whereas in this case, it turns out to be non-blocking condition. That is, one statement's execution is not affected by the other, but there is a certain change in the operation, how it deals with. That is what we had seen in the race condition. We had observed in the race condition. So here we can just observe an example. So they have declared some variables of reg and integer data types. In the initial block, we have within begin and end, we have the same statements which they have provided here. So these are blocking statements.